Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 3 video on the chapter of cubes and cube roots, where I will discuss about cube root of a number, how to find cube root of a perfect cube using the prime factorization method, some properties of cube roots, and finally uh, we will discuss the concepts by solving some problems from the exercise 4C from the textbook of author RS Aggarwal. So if you have not watched the previous two videos, part 1 and part 2, I highly suggest that you watch them to maintain the continuity of your study of the chapter of cubes and cube roots. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos for the first time or visiting my channel for the first time and my videos are beneficial to you, then I strongly request and suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes prepared on the left hand side, and on the right hand side I will do the discussion and solve the problems from exercise 4C. So in this video I will discuss about cube root of a number. Okay, so I will not read through the notes line by line, but you can refer my notes as and when I speak and discuss. Okay, so what is a cube root of a number? Let's say we are given a number uh, uh, y. Y is a number. Now this number y can be positive or negative, because we know that uh, can be positive or it can be negative. Now, what is its cube root? The cube root of y, the cube root of a number y is denoted by uh, so cube root. First, let's discuss the notation. Cube root. Okay. Now, what is a cube root? So the cube root of y of a number y is denoted by the symbol. This symbol. So on the top left corner of the square root, it's basically the square root symbol, but on the top left corner you write the number 3. This means that it is a cube root of y. So cube root of y will be a number x, such that uh, x cube, if you take the cube of x, you will get the number y. So for a number y, its cube root will be a number x such that the cube of x is equal to y. So for any number y, if there exists, so for any number y, the cube root of y is basically a number x such that the x cube will be equal to y. So I have some examples in the quick notes. This quick notes PDF will be attached. The link of the quick notes PDF will be given in the description below, so you can check the quick notes from there. For every concept, I have given some few examples for your understanding. Okay. So this is cube root of a number. Now remember that the cube root of a negative number also exists. For example, we know that cube root of a negative number is a negative number. So we know that, let's say, minus 4 cube is equal to minus 4 multiplied by minus 4 multiplied by minus 4, which is equal to minus 64. So this will imply, we see that for the number minus 64, there exists minus 4, whose cube is equal to minus 64. So we can say that the cube root of minus 64 is equal to minus 4. So cube root of a negative number exists. There is a cube root of a negative as well as positive as well as negative number, and cube root of a positive number will be positive and cube root of a negative number will be negative. So from here, uh, mm, so we can say that if cube root of y is equal to x, then we can say then we can say then y less than 0 will imply x less than 0, and y greater than 0 will imply x greater than 0. That is, this basically means that cube root of a positive number, cube root of a negative number is a negative number, and cube root of a positive number is a positive number. Okay, I hope the concept of cube root of a number is clear. Okay, now how do we find the cube root of a perfect cube using the prime factorization method? So what is a perfect cube? A perfect cube, perfect cubes are like perfect cube are natural numbers uh, uh, for which there exists another natural number whose cube is the so perfect cubes. We know that perfect cubes, some examples of perfect cubes are 2 cube, that is 8, or you can say 5 cube equals to 125. So 125, 8, these are perfect cubes, or even let's say so minus a 4 cube we know is no perfect. We will not consider negative numbers, because perfect cube is a natural number, and natural numbers are never negative. So perfect cubes are natural numbers for which there exists another natural number such that whose cube is the given natural number. So 8, 125 and 4 cube, for example 4 cube, that is 64, these are perfect cubes. So given a perfect cube, how do we find its cube root? That is given 8, given 8, how do we find the cube root of 8 will be 2. How do we find 2? Given the 64, its cube root we know is 4. So how do we find 4? Using the prime factorization method. Let me quickly see if everything is visible or not. Okay. So there are 4 steps involved in finding the cube root of a perfect cube. So first step is you express the given number as a product of primes. That is, you find the prime factorization of the given number. Then step 2 says form triplets of equal prime factor from the product of primes. So in step 1 you have expressed the number as a product of primes. From that product of primes you form triplets of equal factor. That is, each triplet will have three prime factors, three equal prime factors. For example, this is okay. It's better we solve a problem to understand this concept. Okay. So in step 2 we form triplets of equal prime factors. Now in step 3 we select one equal factor from each triplet. We select one factor from each triplet, and if we take the product of those factors, that product is the required cube root of the given number. So there is examples in the notes. You can check that out. Now properties of cube root. Now before let's try to understand the prime factorization method to find cube root of a perfect cube using some by solving some problem from the textbook. Where is my uh, let me see if you can see it properly. Okay, so let's try to find the cube root. I'm I am solving some problems from exercise 4C as illustrative example to explain the concept. Okay, so exercise 4C, let's say, let's start with some simple examples. We have to find cube root of 343. Cube root of 343. So what do we do using the prime factorization method? Okay, so the first step is, as per the steps in the notes, first step will be to find the prime factors of the given number. So let's see, let's do the prime factorization of the number 343. I know this is 7 cube, so it will divide by 7. 7, 28, no, 7, 4, 28, 6, 9. Okay, so 343 is nothing but 7 into 7 into 7. This with simple. We have so this is the prime factorization of the number 343, and in the step 2 we will form triplets from the prime factors of 343. That is, there will be only one triplet, this one, and the triplets, we usually group the triplets with a parenthesis or brackets. Now in step 3, we take we select one factor from each triplet. So since there is only one triplet, we will consider one factor from the triplet. So this is a 7. In the step 3, we only find one factor. Since there is one triplet, we will have one factor. Now step 4 will be all the factors that are selected in step 3. The product of the factors of those factors will be the square root of 343. So we can say now that square root of 343 is the product of all factors obtained in step 3. And for this example, the only factor we got is 7. So 7 is the cube root of the number 343. Let's do another problem number 4. We have to find the cube root of 1728 is in the notes, so I will not do that. So let's do another problem. Let's do problem number 5. That is 92 cube root of 9261. 9261. Okay. 9261. 1, 0, 7, 18, 81. Okay. So okay. So now I really struggle in doing the prime factorization of number, but anyway, let's try. So first we have to find the prime factorization of the given number 9261. So let's do the prime factorization of the number 9261. I hope it will divide by 9. Let's see, 1, 0, 9, 2, 18, and 8, 9. Okay. Now 1029. 1029. Will it divide by 3? Yes. So 3, 4, 3. And 343 we know is 7, 49, and 7, 7. Okay. So 9261, the prime factorization will be 9 into 3. So 9 we can say 3 into 3, and then we have 3, and then we have 7 into 7 into 7. So this is the prime factorization of the given number 9261. This was step 1. Now step 2 is that we will form triplets from the prime factors. That is, we will group equal three equal fact. We will group three equal factors. Three equal factors makes one triplet. So there will be two triplets from the prime factors. This is one triplet, and this is so 3 into 3 into 3 is the one triplet, and 7 into 7 into 7 is the second triplet. So we have formed the triplets. Now in step 3, we will select one factor from each triplet. So from this factor, from the first triplet, we get 3, and from the second triplet, we get 7. So these are the factors 3 and 7 selected. And finally, in the step 4, we will find the square root, or we will say that the square root of the given number is the product of the factors selected in step 3, that is 3 into 7, that is 21. So 21 is the cube root of 9261, or we can say that 21 cube is equal to 9261. Let me quickly check if I did it correctly or not. 21. So 21 cube is 9261. Okay. Let's do 8000 is, I think 8000 will be simple. Now this is problem number 7. We have to find cube root of 8000. Now, if you are asked, when you are asked to find the cube root of any number, obviously you can, most probably you will use prime factorization method, but sometimes it is you need not follow all the steps perfectly to find the cube root. You can sometimes do it orally. For example, if we are so we have to find the cube root of 8000. Now 8000 I know is equal to 8 multiplied by 1000. This is equal to, I know, 2 cube multiplied by 10 cube. So this is equal to, I know, 2 into 10 whole cube. Now whenever, if this is the case, if the given number 8000 is equal to 2 into 10 cube, then obviously we can say that cube root of 8000 will be equal to 2 into 10. There is some so if a number you can easily express it as the powers of some factors, and that factors could be prime number, or even it may not be prime number, and if those if the powers of those factors is a multiple of 3, then also you can quickly find the cube root. For example, if you have any number n, let's say n is a given number, and you have found factorize it in the form of powers of some numbers, let's say x to the power m, whatever this m is some natural numbers, let's say, and let's say it is y, x to the power m and y to the power n, let's say. N is a number, you have expressed it as x to the power m and y to the power n, and where x and y are some natural numbers, and m and n are also some natural numbers. So cube root of n, if n is a perfect square, then definitely the m and n will be multiple of 3. The powers m and n will be multiple of 3. So from here you can say that the cube root of n will be x to the power m by 3. The powers will get divided by 3, n by 3. So that is the reason when we expressed 8000 as 2 into 10 whole to the power 3, the cube root of 8000 was 2 into 10 whole to the power 3 by 3, which is 1. So 2 into 10. which is 20. Okay, let's do the problem number 8. We have to find the square root of 3375. Okay, so sometimes it may not be obvious to find for 8000, for the problem, for the number 8000 it was very obvious. I can orally do it, that orally do the orally express it as a factor of some powers, where the powers are multiple of 3. But sometimes it is necessary to do the prime factorization. So for the number 3375, it is not obvious what will be the factors and the powers. So I have to do the prime factorization method. So prime factorization of the number. So if I divide by 5, this is 6 and 7, 675, and again divide by 5, this is 1, 35, and then again divide by 5, this is 27, and this is 3, 9, 3, 3. Okay, so the prime factorization of the number 3375 is equal to 5 multiplied by 5 multiplied by 5 multiplied by 3 multiplied by 3. So in the step 2, I will form the triplets from the prime factors, and it will be, the first triplet is 5 into 5 into 5, and the second triplet is 3 multiplied by 3 multiplied by 3. In the step 3, I will select one factor from each triplet. So from first triplet I get 5, and from second triplet I get 3. So finally the cube root of the given number, that is 3375 will be equal to the product of the factors obtained in step 3, that is 5 into 3, that is 15 is the cube root of the number 3375. Okay, so this was about finding the cube root of a perfect cube using prime factorization method. Okay, let's see what is the next topic. Properties of cube root. Okay, let's understand some properties of cube root. So the first thing is that the cube root of a negative number, that is first property is that cube root of some negative number, let's say if x is a positive number, then minus x will be some negative number. So cube root of minus x is a negative number, so its cube root will be equal to negative of the cube root of x. Negative of the cube root of x. This is something you must clearly understand. We know, you know that cube of a negative number, we know that cube of a negative number is a negative number. This is the reason why, why the cube root of a negative number is also a negative number. So cube root of a negative number, that is minus x, will be equal to negative of the cube root of x, and cube root of x will be positive number since x is positive. So for example, cube root of minus 125 is equal to negative of cube root of 125, and cube root of 125 is, we know, is 5. So cube root of minus 125 is minus 5. Okay. Property 2 is that the product of the cube root of product of two numbers x and y, where x and y can either be positive or negative. So the cube root of product of two numbers x and y is equal to the product of their cube roots. That is, cube root of product of two numbers, that is x and y, where x and y can be positive or negative numbers. This is equal to the product of the individual cube roots, that is the cube root of x multiplied by cube root of y. Now, this will be very useful. Sometimes you will be given uh, uh, sometimes you will be given this form, and for convenience you will need to for convenience purpose you will need to express this on, as the right hand side the expression, and sometimes you will be given the right hand side a number in the form of the right hand side. Then it will be convenient or useful to convert that to the left hand side. Okay. uh, so this is the basic formula, or the result, you can say, properties. Let's discuss all the properties, then we will solve some problems. The third okay, so for example, let's see some examples. Let's say cube root of cube root of 8 multiplied by, let's say, 27. Now, if you are given the form on the as the left hand side, that is cube root of x multiplied by y, and if you see both x and y are perfect cube, then you can express that as a product of individual cube roots. So I can see that cube root of 8 multiplied by 27, 8 is a cube, perfect cube, 27 is also a perfect cube. So I will express it as cube root of 8 multiplied by cube root of 27. So this will be equal to 2 multiplied by 3, that is 6. But sometimes the x and y, one of the x and y may not be a perfect cube, or none of x and y may be a perfect cube, but the product x and y will be a perfect cube. Let's say okay, so let's say uh, let's say we are given to find the value of cube root of 4 multiplied by cube root of 16. If you are given this expression to find the cube root of 4 multiplied by cube root of 16, we can see that 4 is not a perfect cube, 16 is also not a perfect cube. But we can see that 4 into 16 is 64, which is a perfect cube. So we would like to express this as cube root of 4 into 16 using the property 2. So now this becomes cube root of 64, which we know is equal to 4. Now, similarly, it could be that you are asked to find the cube root of minus 4 multiplied by cube root of 16. This will be equal to you know that minus 4 is definitely not a 4 is not a perfect cube, 16 is also not a perfect cube. But if I multiply minus 4 and 16, I get 64, which is a perfect cube. So I will do as this will be cube root of minus 4 multiplied by 16. This is cube root of minus 64. I know 64 is a perfect cube, but we are having a negative sign. We are having minus 64, but we know that the cube root of a negative number is nothing but negative of the cube root of that number without the sign. So we will have this. Now this is equal to 4. So we are having minus 4. Okay. So, okay. So, property number 3 is basically cube root of a rational number. So, if you are given, if you are asked to find the cube root of a rational number of the form x by y, where obviously x by y is a rational number, then this is equal to cube root of x divided by cube root of y. Now, similar to the property number 2, you will have to you will have to sometimes convert from the left hand you are given the left hand expression, you have to convert that to the right hand expression, and vice versa, depending on the values of x and y. If both x and y are perfect cube, then definitely you would like to use the right hand side form. But if you are given the right hand side form, that is, if you are given this form and none of and if one of x and y or both are not a perfect cube, then you would like to express the right hand side in the form of left hand side, and maybe after some cancellation, the x by y will have some numerator and the denominator which will be perfect cube. Let's see. For example, let's say if you are asked, so cube root of 8 by 125 is, obviously we can see that both x and y, that is 8 and 125, are perfect cube. So it will be cube root of 8 divided by cube root of 125. So this is cube root of 8 we know is 2, and cube root of 125 we know is 5. Also, that cube root of in the x and y, the rational number, it can also be negative. Like say minus 27 by let's say 64. If this is, you have to find the cube root of minus 27 by 64. So you know that the minus 27 by 64, both the ignoring the sign, you can see the both the numerator and the denominator are perfect cube. That is, 27 is a perfect cube and 64 is also a perfect cube. So you can express this as a cube root of minus 27 divided by cube root of 64. So this will become, now cube root of minus 27 is a negative of cube root of 27, and this is cube root of 64. So this is now minus 3, cube root of 27 is 3, we are having negative 3 divided by 4. So this is equal to minus 3 by 4. So this was an example where both x and y are perfect cubes, irrespective of their sign. X could be negative, y could be negative, but irrespective of their sign, ignoring their sign, the absolute value is a perfect cube. Now let's say if you are asked to find the cube root of let's say 16 by let's say 54. Let's say not this, but let's say you are asked to find the value of cube root of 16 divided by cube root of 54. Now you can see that 16 is not a perfect cube, also 54 is not a perfect cube, but you can realize that we know that this will be equal to cube root of 16 by 54. And if you do a cancellation, if you simplify 16 by 54, you will see it is becoming 8 by 27. So this is equal to cube root of 8 by 27, and now you see that both the numerator and the denominator, that is 8 and 27, are both perfect cube. You can now rewrite it as cube root of 8 divided by cube root of 27. This is equal to 2 by 3. Okay. Now, you should also, so property 4 is that if you have inside the cube, if you are asked to find the cube root of some exponential term, let's say you are asked to find the cube root of x to the power m. X is definitely a non-zero, a rational number. It could be a rational number, it could be integer, it could be integer or a rational number. Now, and m is let's say m is also let's say m is a positive integer. Now, what will be its cube root? Its cube root will be, let's say x is a positive number. So, if you are asked to find the cube root of some exponential term where the base is a positive number and the power is some integer, this will be x to the power, the base remains the same, but the power gets divided by 3. The power gets divided by 3. This is also a property of cube root. Just like it is also the same for square root. Like square root of x to the power m is nothing but x to the power m by 2. The power gets divided by 2 in case of square root, and the power gets divided by 3 in case of cube root. Okay. So, if you are asked to find, so what will be, let's say, the cube root of 4 to the power minus 6. 4 to the power minus 6. Now, this is equal to, you can directly, if you remember this property, you can directly say this is equal to 4 to the power minus 6 divided by 3. This is equal to 4 to the power minus 2. This is equal to 1 by 4 squared. This is equal to 1 by 16. So, using the direct property that cube root of x to the power m is equal to x to the power m by 3, you can find this kind of, evaluate this kind of expressions. Now, this could have also been evaluated like this. So, cube root of 4 to the power minus 6, 4 to the power minus 6 is nothing but 1 by 4 to the power 6. We know that x to the power minus m is equal to 1 to the power 1 by x to the power m. So, we have cube root of 1 by 4 to the power 6. Now, we know this will be cube root of 1 divided by cube root of 4 to the power 6. Now, cube root of 1 is 1 and cube root of 4 to the power 6 is 4 to the power 6 by, you can say 3. 4 to the power 6 divided by 3. So, this is equal to 1 by 4 square. This is equal to 1 by 16. Always, so these two formula is very important, and you should remember or realize this concept of formula. Okay. So, if you have, so property 5 is just an extension of the property 4. So, if you have something like a product of exponential terms, if you are asked to find the cube root of some product of some exponential term, so let's say there is an exponential term, let's say so the result is that, let's say you have let's say I have some exponential term x to the power m multiplied by y to the power n multiplied by z, where x, y, z are some non-zero numbers and m and p are some integers. Let's say some integers, powers are some integers. So, this is the number, given number, and you are asked to find its cube root. you are asked to find its cube root. So this will be equal to you just divide all the powers by 3. So it will be x to the power m by 3 multiplied by y to the power n by 3 multiplied by z to the power p by 3. As an example, if you have, uh, if you are asked to find the cube root of, let's say uh, 3 to the power minus 9 multiplied by 5 cube multiplied by 4 to the power 6. So this will be equal to, it will be the same exponential terms, but all the powers of the exponential terms, all the powers will get divided by 3. So this will be 3 to the power minus 9 by 3 multiplied by 5 to the power 3 by 3 multiplied by 4 to the power 6 by 3. This is equal to 3 to the power minus 3 multiplied by 5 multiplied by 4 square. Okay. What else do we have? So these are examples. So that is all regarding the cube roots of numbers. Now let's see. Let's do some more problems from the exercise 4C. It's all about 4C. Exercise 4C is all about finding cube roots of some numbers. So let's do some more problems. Exercise 4C. Let's say problem number 15. We have to find the cube root of minus 64 divided by 343. Now some numbers, some cubes, some perfect cubes, you have to be very well aware of. Like 125 is a perfect cube, 343 is a perfect cube, 343 is equal to 7 cube, 64, 125, then 729. All these some standard numbers which are perfect cubes, you must remember, or always you must be well aware of, so that you can quickly know what will be their cube roots. Now we can see that so this is a cube root of a rational number, negative rational number, where the numerator is minus 64 and the denominator is 343. 64 is a perfect cube, 343 is also a perfect cube. So I will like to rewrite it as using the property 2, not 2, using the property 3, that is the cube root of a rational number. This will be cube root of minus 64 divided by cube root of 343. Now cube root of minus 64, you should is minus 64 is negative of cube root of 64, and cube root of 343 is we know is 7. So this is equal to negative of cube root of 64 is 4. So the answer is minus 4 by 7. Minus 4 by 7. Since in this example the rational number inside the cube root, it was minus 64 by 343, and both the numerator and the denominator were perfect cubes. Minus 64 is a perfect cube because minus 64 is a cube of minus 4. 343 is also a perfect cube. 343 is cube of 7. So we rewrite it as the cube root of the numerator divided by the cube root of the denominator. Okay. Let's do problem number 16. You have to find cube root of 64 multiplied by 729. So this is of the form cube root of x into y. And we can see that x into y here in this problem 64 and 729, they are both perfect cube. 729 is the cube of 729 is the cube of what number? 729. If I do prime factorization, 729 divided by 3, this is 3, 4, 2, 4, 3, and this is 3 again, 81. 81, okay, and this is 327, okay, fine. Okay, so we can see that this is equal to cube root of, you can clearly see that 64 is a perfect cube and 729 will also be a perfect cube, because 729 is, we can see 3 into 3 into 3 into 27. Now, so we can rewrite it as cube root of 64. So using the property 2, we can rewrite it as cube root of 64 multiplied by cube root of 729. 729. Now this is, we know cube root of 64 is obviously 4, and cube root of 729. Now what will be cube root of 729? For that, it is better if you express 729 as powers of prime factors. So we will have 3 to the power 3, because we can see 3 to the power 3. Also we can see multiplied by 27 is also 3 to the power 3. So from here we can, so this is 4 multiplied by, we can say a cube root of 3 raised to the power 3 multiplied by 3 raised to the power 3 is 9 raised to the power 3. 9 raised to the power 3. Now this thing is will be equal to 4 multiplied by, now I can use the property 4 from the in the notes. If you refer the notes, property 4, I can use that property and say that cube root of 9 to the power 3 will be equal to 9 to the power 3 by 3. So this is equal to 4 into 9, that is 36. So 36 is the cube root of so the cube root of 64 multiplied by 729 is 36. Okay, let's do few more examples, problems. Problems 17, cube root of 729 divided by 1000. This is also of the form cube root of x by y. Then we can see x is 729 and y is 1000. And 729 is a perfect cube because we just saw in problem number 16, 729 is equal to 9 cube. 729 is equal to 9 cube, and 1000 is also, we know, 10 cube. So we can rewrite this as cube root of 729 divided by cube root of 1000. So this is equal to cube root of 729, you can write it as 9 cube, and 1000 you can write it as 10 cube. So this will be now equal to cube root of 9 cube. Using the property 4 again, we can say this will be 9 to the power 3 divided by 3, and the denominator will be similarly 10 to the power 3 by 3. This is equal to 9 by 10. Let's do the last problem. Problem 18. We have to find the cube root of minus 512 divided by 343. 343. Okay. So we know that 512 is also a perfect cube. It is the cube of 8. 343 is also a perfect cube. It is the cube of 7. uh, 7. Uh, yes, 7. So we can rewrite this as, since this is the cube root of x by y form and both x and y are perfect cube, we would like to use the property 3. That is, this will be equal to cube root of minus 512 divided by cube root of 343. So this is cube root of minus 512. We can write it as a negative of cube root of 512 and divided by, we have cube root of 343. Now uh, uh, 512 we know is 8 cube, and 343 is we know is 7 cube. So now we can now use the property 4 and say this will be equal to negative cube root of 8 cube is 8 to the power 3 by 3, and this will be divided by cube root of 7 cube means 7 divided by 3, 7 raised to the power 3 by 3. So this is equal to minus 8 by 7, minus 8 by 7. Okay. So this brings to an end of solving most of the problems from exercise 4C based on cube roots of a number. So we have discussed what is a cube root of a number, and that cube root of a negative number minus x is equal to negative of the cube root of x. And we saw the prime factorization method to find the cube of a perfect cube. That is, what is a perfect cube? Perfect cube is a natural number for which there exists another natural number. Y is a perfect cube where y is a natural number such that there exists another natural number x whose cube is y, that is x cube is equal to y. Then we saw some properties of cube root, that is the negative cube root of minus x, negative x is equal to negative of cube root of x, and then cube root of x into y, where x and y are x and y are either positive or negative numbers, that it is equal to cube root of x multiplied by cube root of y. Similarly, cube root of some rational numbers, a rational number, cube root of x by y will be equal to cube root of the numerator divided by cube root of the denominator. And some extra properties. Property 4 is that cube root of an exponential term will be equal to that same exponential term, but the power will get divided by 3. So I hope this video was beneficial in understanding the cube root of a number and some of the properties of cube roots and the prime factorization method to find the cube root of a perfect cube. And this was beneficial to understand the concepts of cube root. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video will be the exercise 3D, which is objective questions which are based on the entire chapter of cubes and cube roots. So I will solve the problems, objective questions of exercise 4D in the next video. So please stay tuned for the next video. So thanks for watching, and until the next video, take care and bye.